That's what's coming up, isn't it?
Yeah.
There we go. Okay. Right. You can write that down. We'll get started. Not a big lesson. This one is not too much in it. Can I ask, which classes do you have in here?
We still have everything.
Chemistry. Yeah. No, we also have maths.
Do we have maths?
Yeah.
Do you have EAP in here?
No.
I don't think so.
Oh.
Let me check.
Anyways, no, I just doesn't matter. Doesn't matter. Okay, force, Newton's second law. Okay, so we all have an understanding of the word force, right? Just from general English. Yeah? We've heard this word before?
Yeah.
Yeah? So what exactly is force?
The product of mass times acceleration.
Oh yeah, and this too. Right, so force. We say force is what changes the motion of an object. That is, force will change either. Well, actually, maybe some of you know. What could force change? What does the force change?
Direction.
The direction, very good. Or,
Speed.
yeah, it'll either change the direction or the speed. Or both, possibly. In other words, force causes an object to accelerate. Now, I think I just, listen. I think it's enough to write this much down. That's enough to write, but there's a little bit extra. Force can do other things too. It can change the temperature, it can change the shape, it can do this too. But it's true to say that if an object is accelerating, then there must be a force. And force is also a vector. So what I'd like you to write down is this much, and also just write force as a vector. I think that would be good too. Now, I keep forgetting to text Joan and Lorraine, so I'm going to say,
For the layout of the class.
yeah, I'm going to text them right now while you're writing that.
My smartphone suit.
Huh?
I like your smartphone.
Thanks.
You still have the predictive text?
Yep. These new seats are not working for me, indeed. Can we go back, please? See, I'm not so sure. I'm not sure if this was Lorraine's idea. So
I think it was English teachers, yeah.
I think so too, but I'm not 100% sure. Right, we'll see if they reply. Okay, did you write that down?
Yeah.
I still see some writing. Yeah?
Yeah.
Good, okay. Now, how do we measure force? What's the unit? I think some of you know this already. What's the unit? Newton. Force is measured in newtons, and the letter is N. Does anybody know what the definition of a newton is?
I think it's
Yeah?
Mass.
yeah.
Yeah, but that, yeah,
Meters. Meters.
nearly, not quite. You're giving me the formula. So, a newton of force is the amount of force required to cause 1 kilogram of mass to accelerate by 1 meter per second squared. If you have this situation, then you have a newton of force. If 1 kilogram is accelerating with 1 meter per second squared, then 1 newton of force in total is acting on it. And I've seen this definition in the exam, so it's worth writing this one down carefully. I'm wondering, the three of you over there, did you all ring each other on the phone this morning and decide to wear black? The three of you, you're wearing black trousers and black top. It's like you're going to go out and rob somewhere later. Go into Spar and steal money or something. It's three of you the same. Criminal gang. Yeah. The engineering gang. Okay, you got that? Yeah, son?
Yeah.
Yep, okay. So, we need to know this definition for the exam. Right, now, cold, warmth. Oh yeah, you can open it, just. Yeah, that's it. There we go. Dorian, I think you knew the formula. What is the relationship between force and acceleration? I think you were saying it earlier, weren't you?
Force is
Yeah.
mass
Yeah,
multiplied by acceleration.
that's it, yeah. One way to state Newton's second law is F equals ma. That's the relationship between F, M, and A. Where F is the net force. Now, who knows what I mean when I say net force?
Resultant.
Resultant force, yeah, or total force. M is the mass, obviously, and the A? Acceleration. In fact, there is another way to state Newton's second law, but we'll look at that in another lesson. Can you just write down this formula? It's called Newton's second law. Put it in a big box. Rather important law. In fact, in mechanics, it's the most important law in mechanics. Okay? Yeah. This formula gives us a realization. If we have F equals ma, what's the unit for F? Newtons. And what's the unit for m? Kilograms. And this is meters per second squared. So, what we can see is 1 Newton is the same as 1 kilogram meter per second squared. So, why is that important? Well, remember these are part of the 7 SI units. Remember earlier I said Newton isn't part of the 7 because you can write it as in terms of the 7. So you can use Newton or you can use kilogram meter per second squared. They are literally the same thing. Okay? There's no difference between a Newton and a kilogram meter per second squared. Yeah? Continue? Yep. Okay. Here's a very simple question I want you to tell me the answer to. A 45 kilogram girl starts to run from rest with acceleration of 2 meters per second squared. What is the force?
99.
Yeah, that's a good yes. Yeah. I hope that didn't use too much brain power. Yeah. Is this your first class?
Yeah.
Yeah, okay, good. Alright, so that one is fine. Yes? F is 90. Alright. Now here's a harder one. So, you see a barista. You all know who a barista is? Coffee maker, very good. The person, not the machine. Yes. You see a barista slide a cup of coffee across the table. The coffee is initially at rest, and you estimate it leaves his hand at 30 centimeters per second. He seems to be in contact with the cup for 1 second. Furthermore, you estimate the mass to be 500 grams. How much force did the barista's hand apply to the coffee cup over the 1 second? So I'll just draw the picture of what's happening here. So you have this picture here. There's the table. And there is the coffee cup. And there's basically his hand is applying a force. Okay? And of course, naturally enough, it's at rest. And then he pushes it for 1 second. And then he lets go. So it's a 1 second push. So the force is there for 1 second. Okay? And at the end, it's going at 30 centimeters per second. Okay? What else do we know? We know that the time here is 1 second. And that the mass is 500 grams. Okay? And I ask you to calculate the F. Now, do we know the M? We do. Do we know the A?
Yes.
Yeah, well, we don't know it, but we could know it. Right? So I'll give you a minute to calculate the force here. Before you begin, there are 2 small problems to fix first. What are they?
Conversion.
Yeah, the 2 units. Yeah, okay. See if you can give me the answer. I'll give you a minute. Yeah. Is anyone here Korean? No. I was told in Korean the word for barista is also barista. It's the same word in Korean. They imported it.
Also Italian, actually. That is.
Yes, correct.
And
Yes,
it's
yeah, yeah, yeah.
more of a
So I suppose
thing, yeah.
we imported it too. Yeah. Is barista the same in anyone else's language? It's a different word.
Spanish is just camarero.
Ah, that's nothing like it. Nothing like it. It translates as coffee maker, or
No, camarero is the one that serves you.
Service drinks.
Yeah, like a server.
Oh, it's
You don't
not.
have a specific name.
Oh, really? Okay.
In Italian, it's not specifically coffee only. It's like a bartender instead.
Oh,
bartender.
we just use it this
Yeah,
way.
basically.
Interesting. Interesting. How are we doing? We got the answer? It should be a small number, shouldn't it? Yeah. Let's check now. So, I know the M. What's the M? It's 0.5. I can get the A pretty easily. It's going to be V minus U over T. Right? And you're saying that works out to be 0.15? 15 newtons. We happy with that?
Yeah.
Easy peasy, right?
Yeah.
Okay. Oh, sorry. Do you need to, what do you need to?
Just 1 second. No, go back to the question.
Yeah.
Oh, it was the last. That was good.
Okay.
I don't understand.
Continue?
Yeah.
Right. I'm giving you another one now. So it's the same story, except this time the difference is you're looking at the second half of the story, which is so let's imagine that this was smooth, but now this part of the table is rough, and what happens is this starts to slow down and it stops. So he pushes it and it moves from here to here and then it stops. Okay? And this distance is 0.9 meters. So I want to know what is the frictional force. So that is, as it's moving, there's some force here causing it to decelerate, to slow down. And my question is, what is this force now? So we'll slide over, and now we're looking at this half of the story. Yeah? Alright, see if you can calculate this F. No time. Although you know the U here, if you look at this as U and this is V, you know the U here is 30.
Yeah.
Because that was the V for the last part.
Yes.
You have U, you have V, and you have S.
And what's the problem asking?
The F.
F.
Mhm.
The F causes the decelerate.
Correct.
And what's the blue word on the
Stops. Right, how are we doing? Are we getting answers?
This question for life, for both.
It's F, yeah. Yeah?
Yeah.
0 to 1.
0 to 1.
0 to 5.
Yeah, good. Okay, let's have a look. So U is 0.3, V is 0, S is 0.9, and we can say V squared equals U squared, is that right?
Yeah.
Plus
80.
1.8A.
Yeah.
So then the A is, what's that, minus 0, 0.01?
0.05.
Oh, sorry, yeah, 5, sorry, not 1. 0.05. Yes?
The mass.
Yeah, so then F is MA, which is negative, 0.025 backwards, correct, newtons, yeah. Now, I suppose my question, yeah, no, I could leave it like that. Yeah, that's fine. Yeah, that's fine. Well, no, I'll be extra clear. 0.0250 newtons, because you want to three significant figures. Or if you really, really want to, you can say minus 2.5 times 10 to the minus 2. Goodness, 2.50 times 10 to the minus 2 newtons then, if you really want to. Okay, can we continue? Yeah. Right, a 40 kilogram child jumps 2 meters off a 2 meter wall into 10 centimeters of sand. What is the magnitude and direction of the force being applied to the child from the sand while the child is decelerating? So, I'll draw what's happening here to make it clearer. What you have is this picture. This is 2 meters. And this 2 meters? Yeah, I guess maybe so.
40 kilograms.
And 40 kilograms. So he falls for 2 meters. And when he lands on the sand, you don't stop immediately because the sand, flattens. So he kind of lands in the sand. So he sinks a little bit. So this distance is 10 centimeters. Now that's important because if you look at the sand is soft. It's when he hits the sand, this is when he slows down. This is the deceleration. Because what's happening as he's falling? He's acceleration, and then this is the deceleration. Okay? So we'll do this one together. What we need to work out, we really care about this part. We really care about knowing the u here and the v here. Well, we know what the v is. It's 0. Okay. How do we get the u? Well, the u here will be the v for this part, which is 0 here. Okay, so let's write down the info. U is 0, v we want, a is minus 9.81, t we want an s, what's s? Minus 2. If we take this as the start. Just to be careful. So how can we get the v? What will give us the v? V squared equals, yeah? V squared, let's zoom out a bit. V squared equals u squared, which is 0 times 2as, which is 2 times 19.62.
6,2.
Are you giving me the final v answer? Yeah, what is it?
6,26 meters per second.
What's anything after the 6?
Yeah, 4.
That's the v.
Newtons downwards.
Meters per second.
Down.
And it's downward, so we better put in a minus.
Okay.
Now, let's look at this part of the journey. What's the u? It's minus 6.264. What's the v? 0. What's the a? We don't know.
Yeah, but
That's what we want. But we do know one thing about it. It will be a positive, because it'll be pointed upwards. That's not a fire alarm, is it? That's good, okay. UVA, T we know, we don't know, and S? Yeah, minus, oh, careful, 0.1. Yeah. Let's get the A. What gives me the A now? For this part. V squared again? V squared equals U squared plus 2AS. Yeah? So A will be positive 6.264 squared over 0.1. So what's that? 392.4. And finally, F equals MA. So that will be 40 times 392.4. Now we can have this to 3 significant figures.
Is it really that much?
Yeah, because he's slowing down rapidly over 10 centimeters. So there should be a huge force upwards when he hits the ground.
15,696.
15,006.
I
Okay.
think it should be minus the two with multiple 0.18.
Here,
2 AS.
2,
Not AS.
2 AS.
Use,
Oh,
Yeah.
yeah,
sorry.
so
This should be a 2, shouldn't it? Thank you.
So it should just be half of that.
so
It should
yes,
just be
I
half of
guess-
that.
I guess it is 196.
Well, yeah, sorry.
7848.
What was the acceleration here? What was the A? 1, 1.
You're doing it now?
Yeah.
31,32.
Huh?
Oh, no, that's squared.
196.3.
Okay, and then 196.2. Thank you. And what's the answer? Won't be as big.
7,848.
So 785.
4.
You said 48.
Yeah, 48.
So
50.
50. Sorry about that. 50 Newton. So that's a lot of force acting on him. But remember, he spent 2 meters accelerating and then only 10 centimeters decelerating. So he's going to need more force for this journey than for this journey.
So in other words, his ankles are broken.
I think, I looked this up before,
2 meters, yeah, right?
I think you can handle 7,000 newtons. I think so. I can't remember what it was, but I think...
And it will break your bones.
No, I think 7,000 is okay. I think your bones start to break, I think, after 10,000 newtons. I think.
I mean, for the Muay Thai fighter, the knee, when they knee someone, it's gonna make them one time.
You take a ton?
Yeah.
Are you sure?
Yeah.
Are you sure?
scientific, Yeah.
Okay, fine. Well, anyway, so 7,000 is okay. Yeah.
But in fact, the press should be divided 2 because you have 2 feet. So in fact, it will not influence your bones. But if you crash down or
True, that 7,000 is total.
yes, and you have 2 feet.
You have 2 feet,
so
so that's less pressure.
the less
And your
pressure.
knees
Yeah.
are not solid.
I suppose we could do an experiment and see. We just need 10 centimeters of sand and 2 meter wall.
Yeah.
Easy peasy.
Questions.
Yeah.
So for this force, which direction?
That, yeah, good question. Guys, which direction is this force?
Upwards.
Upwards. Because he's fallen into the ground, the sand, and the sand must be pushing up to slow him down.
Just
Yeah.
looked it up. It says it in our web page that it takes 4,000 newtons of force to break a typical human femur.
Only 4,000 newtons.
That's what they say. I mean, I don't know if it's.
But as he was saying, he has 2 legs, so this force will be split over 2. So just about okay.
And your legs aren't solid in your
They can, yeah.
Absorb
Yeah.
some of the force.
Yeah, okay. Might be okay. Also, he's a child. He's
Yeah.
more flexible too, so that will help as well.
And he heals.
And he'll heal faster too. Yeah. Right. Okay. So look, there's a few minutes left. You can get a start on the homework then for this one. Okay.
For tomorrow. So.
For tomorrow. Yeah.
Why
Just this
did
lesson.
they give us a double, do you know?
Why what?
Why didn't they give us a double today?
Well, it's because I have a maths class after this. You see.
But
I
mean,
said-
we only
Earlier.
started at 10.
Yeah. You could start at 9. It's 1
Yeah,
hour.
it's possible, but I don't know. Oh, this room is free, isn't it?
Yeah.
Yeah,
No one was here.
last Monday we had.
Strange. We don't usually have students looking for class at 9 o'clock on Monday morning.
No,
I tell you what, just wait a few weeks, and if you still want this, we can do this, because I'm free at 9 o'clock. I think this room was free, wasn't it?
Yeah, I'm just thinking for your sake, it's,
For having the double class. Yeah.
So isn't it easier to get through the content in the double than rather than a single?
I don't, to be honest, I don't mind splitting the lessons up into two halves.
Question
Because
for
the advantage of that is the homework comes at a steadier pace. Yeah?
5 questions for tonight, right?
Is it 5 questions?
Yes.
Okay, we can start now. That's not so bad.
So your server was down for
Yeah.
a little while
Yesterday.
Oh, sorry, I was doing lots of maintenance on it and then I broke it and I had to fix it. Yes, I forgot that with my server's down, you can't see the questions. I was doing it was one of those situations where you do an update and then you break it
Yeah.
and you're like, oh rats, what did I do that broke it? So I had to figure out what it was. And then after I fixed it, there was still a problem. Somehow the settings changed so that the upload limit was reduced to 2 megabytes. So I couldn't upload my files that were bigger than 2 megabytes. So I had to figure out what went wrong. But it seems to be, I checked this morning and it seems to be working fine. So
You know, yesterday it was working, it was just like around, 2 something, 3 p.m.
And it was down until
Yes.
like 7 or so.
yes. You were probably you were getting a 500 error. Yeah. I accidentally disabled a key module that was necessary for the server. It took me a while to figure out which one it was. Anyways, it's fixed and I made a backup of it as well, so it should be okay.